Yeah. So myself and Tyndall, we really talked about, our experience and our observations, kind of building AI factories at scale. So we've been in the middle of, constructing 590 megawatts over the last year. And I think it was a great opportunity with the DCAC team to really share our experiences, what we're learning, what we're figuring out, what are the key fundamental challenges, in hopes that, everyone else can sort of take advantage of that and learn where and take advantage of where we've learned and where we haven't. Many of them, but I think the most fundamental, like first principle challenges, is that the pace of innovation at the compute stack layer and makes it really challenging is faster than the design builds. So the data center builds take 18 months, 12 to 18 months to build. We're seeing that the rate of innovation within the GPU stack is happening much quicker than that. So meaning that the requirements are changing as you're trying to build. And once you get the build done, like you're already iterating on a totally different generation of compute platform. And so that's the number one challenge, I think, for us. Oh, certainly. I mean, like, again, building as fast as we're trying to build at the scale we're trying to build is always resource constraints, skill set constraints. We're trying to, even through our commissioning processes, is like, how many OEM techs do we have? We have hundreds and hundreds of Delta UPSs. We need to commission all of them almost at the same exact time. And so, and Delta only has 104 techs here in North America. And so we would have really a technical constraint that is something that we have to try to solve for, while we're trying to build the ship. From an industry standpoint, it's thousands of technicians. It's not just thousands of technicians that specialize and that are sort of equipment specialists, but it's also technicians and facility operations and maintenance. The number of electricians that we need to actually build these things. We have one project that has over 1,300 people working on it, 1,300 tradesmen working on it, 600 electricians. It's the amount of resources we need and the specific skill sets that we need to bring these projects to fruition. There's just not enough of them across North America to bring all these projects to life, right? And so what does that mean is investing in training for the employees that we have, retraining, cross-training. In some cases, we may have to import from other regions of the world just to get the manpower necessary to bring these projects out of the ground. Yeah, this industry is, I would say that the mature aspect of the data center industry is nearly 30 years old. Gone through most of the people that are working here started, 30 years ago. We're kind of getting to retirement age for a lot of us. I still got a few years left. Not there quite yet. But there's a big part of our workforce that is going to be exiting the workforce here over the next 10 years. And so, now is the emphasis on thinking about, how do we get people interested in the trades? How do we get more electricians? How do we get more journeyman electricians? How do we get more mechanical engineers? Like, all of this is actually needed to, sustain the growth long term. It is unparalleled opportunity. Like the growth, just the pure growth, which is not going away anytime soon. The demand will obviously breed opportunities in a number of different ways. There's going to be more opportunities for more jobs, and like the pay scale and the salaries for these jobs are just going to go up from now. Like, these are going to be very highly skilled, highly paid, heavily sought after skill sets, in the workforce. So I think anybody that is leaving high school right now, thinking about where they're going to go to college, I think looking at either going down an engineering path or going down a trade path, like, they'll have all the opportunities they could even dream about. It's exactly that. It is sharing knowledge, being part of the community. Yes, we have competitors in the audience, and we also have customers in the audience, and we have like a mix of a community here. But everyone's trying to figure out how to do the same thing. It's like, how do we do this the right way? I think the industry as a whole, right? I think the economy as a whole needs us to be successful, and we need each other to be successful. So I think the platform here at DCAC lends itself that type of dialogue. What are you doing? How do I learn from that? How can we partner together? Like all that's it. All that's here. Well, I think today is like what used to be. I think these two worlds are actually kind of really blurring the lines between them. What used to be, you would never think of like a tertiary market where you'd have a Bitcoin mining facility, and that would be kind of out of play for in an enterprise data center or a colocation data center. Like no one would go to think of like building in Timbuktu, Alabama, right? Versus being in Atlanta. Like you want to be in Atlanta for a lot of obvious reasons. However, like the power landscape, the utility landscape is forcing this migration into secondary and tertiary markets or regions of the U.S. in particular, but I think it's also happening worldwide. And Bitcoin miners are actually at the frontier of that because they were already built in some of these tertiary markets with large scale utility infrastructure. And so Core Scientific, we sort of found ourselves kind of in the right place at the right time with the right strategy, sort of the bring those things together because we sort of saw where this was headed. Like, hey, we need to make this decision. We've seen others in our peer group make the same kind of transition or planning to make the same kind of transition. And I actually think fundamentally, like this seems like to be more of a natural evolution of the internet, where the internet's going to chase where the power is ultimately at the end of the day. And I think we're just seeing this play out in real time.